Now, time value of money. Now, as a student now, you need to understand that you have to learn to tell the difference now between lump sum cash flows and annuities. Now, I'm going to bring you through, using your PVIF tables to solve annuity problems, your FVIF tables to solve annuity problems, and then I'm going to do the same thing with the annuity tables. So I'm going to step you through each one of the 4 tables and give you an example so that you sort of understand a bit. Now, we're going to talk about present value interest factor now, and we're going to talk about lump sum cash flow. Now, in lots of textbooks, they suggest, and they show you in a lot of textbooks now, a diagram of the problem. And usually it'll look something like this. That is, you know the lump sum cash flow in the future, but the question is, what's it worth today? Now, note that the unknown is in the present. This is a lump sum problem. If the unknown's in the present, you use your present value interest factor table. So that's an indicator of which table to use. So this is a PVIF problem. To solve the problem, to get the answer that you're looking for, whatever the question is now, it's the known lump sum cash flow that you know in the future, multiplied by your present value interest factor. And to look up a PVIF or any interest factor, you have to know the N and the I. As an example, let's say that today you found out that you have a new niece or nephew, a new baby in the family. And you decided that you're going to put enough money away today so that you can pay the first $10,000 of this child's tuition when they go to college. Now, at that point now, we know the lump sum cash flow out in the future. It's $10,000. You go down to your bank and you go into the bank and say, I'd like to set up a certificate of deposit. Now, in investments, a CD is known as a lump sum cash flow. You put one amount in, you get one amount out. And so you go to your bank and you say, I'd like to set up a CD to provide my new niece or nephew with this money to go to college. And so the question is, how much do you have to put in today in order to have $10,000 18 years from today? So your banker tells you, if you're going to put your money in here in this CD for 18 years, we'll pay you 4% per year. So again, the question is, how much do I have to put in the account today so that it earn 4% every year for 18 years? And 18 years from now, I have exactly $10,000. Here's the little formula. This is a lump sum problem. You know the amount out in the future. The question is, what's it worth today? That's in the present. We're going to use our PVIF table. This is the little functional formula that you'll use to solve a PVIF problem. So the unknown, what we're looking for, is going to be equal to the known lump sum cash flow, which is how much money we want to give this child 18 years from now. And we're going to multiply that known lump sum cash flow by our present value interest factor. N in this case is 18 years. That's when the child's going to go to college. 4% is 4% per year. That's the interest you're going to earn on the money. Something we'll talk about later on, but I'll tell you right now, you have to match up the N and the I. If N's in years, I's in years. That is, if these are 18 years, then I need to know my yearly interest rate. If N would be in months, 18 months, then I would need to know my monthly interest rate. But again, we'll get back to that a little later, but that's something that you're going to have to deal with later on. So if we plug in what we know into this problem now, we know that we're going to give the child $10,000 18 years from today. We go to our PVIF table. You look up N equal to 18 and I equal to 4%, and you'll find an interest factor of 0.4936. And if you multiply that by 10,000, you get the answer, which is $4,936. So if you put $4,936 in an account today, and it earns 4% per year, 18 years from today, T18, the end of the 18th time period now, you'll have exactly $10,000.